Hi, I am Chandrasekhar Gupta and we are discussing programming concepts. Now we are going to discuss about trees. Before talking about them, I want you to remember about linked list. In the case of linked list, we are having a head node and we are trying to keep track of the address of the next node in this node. And in this way, we are trying to keep track and traversing the list in a similar fashion, in one direction. But in real world scenarios, when you are trying to simulate artificial intelligence software, you need to take decisions dynamically depending upon the answer. If your answer is yes, you have to go and suggest something. If your answer is no, you have to suggest something else. In this case, we can make a good use of trees. Trees are defined similar to linked list, but the only difference is it is having two pointers, left pointer and a right pointer, whereas a linked list is having one pointer to the next node. Let's have a look.
Let's try to understand trees. We have many type of trees such as binary tree, ternary tree, or even n-ary tree. Binary tree can have 0 children, 1 or 2. So, it can have at most 2 children. Ternary tree can have at most 3 children. N-ary tree can have n children at most. So, each and every part of a tree can be called as a node. And these nodes are connected with branches. The node which is located at the top of the tree can be called as root, and the nodes at the bottom level can be called as leaves. This node which is called as root can be represented with it is at height 0 or in level 0 or at depth 0. We don't have a precise definition for height, level and depth. Some people term it as 0th level, some people even call it as first level. Whatever it is, whenever a problem is given, it will be specified clearly whether the root is at 0th level or first level. The same happens with height and depth as well. Except leaves and root, all the other nodes are called internal nodes. Let's see some of the basic questions that can be asked in trees. Consider this question: maximum number of nodes at level L in a binary tree. For solving all of these type of questions, you can take an example. Let me take an example here. Let me call it level 0, level 1 and this is level 2. If you just see, at level 0 I am having 1 node, at level 1 I am having 2, at level 2 4 nodes respectively, which are 2 power 0, 2 power 1 and 2 power 2. So, at level L, we are having 2 power L maximum number of nodes if it is a binary tree. For solving all of these type of questions like what are the maximum number of nodes possible for a particular number of branches and so on, you can take an example and you can solve it very easily. Even this question, in a binary tree with n nodes, minimum possible height or minimum number of levels. You can take a tree, you can assume a value for n, let's say n is equal to 15 or something. You can take a tree, then you, with the help of n, you can represent it in form of a tree with this many number of nodes and you can find out the height or levels or whatsoever which is asked. But just make sure before you mark the answer, try it with 2 or more examples, just to be clear. Now, let's come back to this binary tree. We know that binary tree can have maximum of 2 children. If we just look at this tree, 1 is the root and 4, 5, 25 are leaves. If we just observe, in the case of a linked list, we can traverse only in one direction and each node is connected to only one node. But in the case of a binary tree, each node is connected to 1 or 2 nodes. So, this node is represented in the left side of the tree and this node is represented in the right side. That is why I can define a node structure. Let's say this is carrying integer data, so I have represented an integer in it and I have a left node and right node as well. As this left and right nodes are similar to the main node, I am even giving the same structure to these nodes. Now, I want to discuss a point over here, that is type def. If we want to create an object for this, we can write it as follows. But instead of writing this thing every time, what I can do was, I can declare type def struct node, and if I given it as capital N, instead of writing this struct node, I can replace it with N now. It can be written as N S1. Now, both of these statements are similar. Type def is actually used to replace a particular keyword with a flexible letter or even another word. You need to remember only one thing. Type def is used to modify only keywords and symbolic names. If you are having an integer and you want to change its name to capital INT, you can just simply write type def, keyword to be modified, followed by the replacement. Now, instead of this integer, you can actually write int and the conversion will be taken place implicitly. Coming back to the topic of trees, we have different type of trees. They are full binary tree, complete binary tree or perfect binary tree. In the case of full binary tree, every node is having 0 to 2 children. This is the node and it should have 2 children or it should not have any children. So generally we are having 3 possibilities in the case of binary tree. We can have 0 children, 1 children, 2 children to any node. But in the case of full binary tree, we can have either 0 or 2 to all the nodes which are present in the tree. Now, we are having complete binary trees. In the case of complete binary tree, I'll suggest you to go with the definition, we should go in sequence. You take a node, you have to fill the nodes in sequence. If you take this tree, all the nodes are filled in sequence. We have started with the root, fill the left, fill the right, and then fill the left of this. This can be a complete binary tree. If you start with the root and if you fill right without any left, it cannot come under the category of complete. So, it should be in sequence. Finally, we are having perfect binary tree where all internal nodes have 2 children and all leaves are at the same level. That means if you consider a tree, this is the root, these are leaves. Both of these are internal nodes. This is having 2 children and this is having only 1 child. So, this is not a perfect tree. But consider this. Now, this is also having 2 children. So, all the internal nodes are having 2 children. The first property is satisfied. All leaves should be at the same level. 1, 2, 3, 4. All these 4 are leaves and they are at the same level. This is level 0, level 1, level 2. All of these are at the same level. So, this satisfies to be a perfect tree.
We have seen about trees and what are the different possible types of trees. In the next video, we'll talk about the most important topic, tree traversal.